Hello, hello, hello. Today we're talking about enumerations. Enumerations is a group of related values. Let's take a look at what enum syntax looks like. So here we'll create an enum using the enum keyword. We'll call it software platform. And here software platform will have three cases. We'll have web, we'll have iOS, and we'll have Android. Okay. So this is a basic syntax of an enum, enumeration, or enum for short, right? So we have the enum keyword, we have the name. Again, we're using uppercase characters here, very similar to classes and structs. So we'll say software platform, and we have the cases. In this case, we have three cases. And the cases convention, we use lowercase. We start with a lowercase character, and we name the case. In that case, we have three cases here. So this is software platform. We'll go on to see how to create an instance of an enum. Here we created the enum type, we defined what it is, but we haven't created an instance. So let's go ahead and create an instance of our software platform enum. So here I'll create a constant, I'll call it platform, and I will use the enum we defined above. And the way I'll get one of the instances, I'll simply just type in dot and the types come up. In that case, I'll just create an iOS instance. Okay. If we were to option click on platform, we'll see it's an instance of software platform enum. Great. Other things we could do, we could use a switch statement, not a Swift statement. We could use a switch statement to basically figure out what instance of the enum or what case of the enum that we have. In our case, we'll go ahead, we'll use a switch statement here. We'll switch on platform, which is the instance here. So this is an instance of the software platform enum, right? So now we want to figure out what case is the user using currently. So in that case, we'll switch on platform using a switch statement. One other thing about enums, they're basically a group of finite related values, right? Preferably finite related values. If they're not finite, then we'll see we have to use a default statement. So if not finite, we have to use, if it's not finite, we have to use a default statement. So a group of finite related values, if not finite, we have to use a default statement. Okay, cool. So here we'll say we'll switch on platform. And in our case, we have three cases. So we'll say case, if it's iOS, just print you're an iOS developer. We'll just go ahead and copy this statement and make it consistent for all three. And then next case, we have Android. We'll also just print you're an Android developer here. And lastly, we have, you see, so right now we're getting an error, switch must be exhaustive. Basically, that means the compiler figures out we have three cases. So here we only account for two cases so far. So we have to either use a default statement like this, where the compiler will be happy, right? Or we could use our last case, which is web, and print you're a web developer, right? And now the compiler is still happy because we have exhausted all our cases. So if you put one case in and you have three cases, To silence the error, you have to put a default statement. So whenever you don't exhaust your switch statement, the compiler will throw an error, meaning you have to use a default or go through all your cases. So here we have an instance of a software platform, Enum, and we instantiated it with iOS. So we should get line 24 to get printed. You're an iOS developer. So let's go ahead and run this display ground. And here we see you're an iOS developer. Because our instance is iOS, we use a switch statement to see what case this is. And in that case, it's iOS, the first one. If it wasn't iOS, then it would go to Android. So simply, if we were to change this to Android, it's no longer iOS. It will print you're an Android developer. Okay? So this is one way to use switch statements to see what instance of an enum you're dealing with. Next, we'll go over iterating over an enum. So in that case, we will create a new enum here. We'll call this one season. And here we have winter. Other things we could do with enums, like we did here, we separated it with 3 cases. But if there's no difference between the cases, you could simply have commas here. So in our case, I could just say case winter, winter, spring, summer, and fall, just like that. Okay. Now we have 4 cases here. Now I want to be able to iterate through my enum. How can I do that? How can I figure out, I know we have 4 cases here, but how can I figure out, or how can I use my season? In other words, how can I use a for loop and say for season in season and go ahead and print each season? So basically that's what I want to do, right? How can I do this? Right now the compiler is going to complain because season is not a sequence, it's not a collection. So how can we do this? Well, as of Swift 4.2, if I'm not mistaken, we have a protocol which we could conform our enum to. So we could conform our enum, our season enum, to this protocol called case iterable. And here, case iterable is a type that provides a collection of all its values. So basically, what that says is now we have the ability to iterate through all those cases using the all cases keyword here. So you see all cases, lowercase all cases, a collection of all the values. So now we have a sequence. We could iterate through that sequence. So if I run my code, I see winter, spring, summer, and fall, right? So where did I declare this? So here, winter, spring, summer, and fall, in the same order that it was added, okay? So this is one way to find or to iterate through the cases of an enum. And you could also, if you could iterate through it, you could find out the count of it. So here I could say print there are, I'll say season dot all cases dot count, because now it's a collection. So there are seasons. Now if I run my code, I'll see there are 4 seasons because we have 4 cases here. Great. Next, we'll go to talk about associated values. Again, we'll create a new enum. We'll call it language. And we will see what associated values are. We'll create a case here. It will be Swift. We'll create the next case. It will be Java. And we'll create a third case. It will be called Objective-C, right? So here we will be differentiating those. So we are using separate cases as opposed to what we did earlier here. We had everything on one line with one case, but there are 4 cases. So here, Swift, now we're talking about associated values. What does that mean? I could associate a value with my enum because right here, winter doesn't have any other value associated to it. So when I print it out, it simply says winter. There's nothing else associated to winter. But with Swift, for example, I could associate a string, any string I want. I could also associate a double, In that case, we could say it's the language or the platform and the version, for example. Right? So string will be the platform. For example, I'm an iOS developer or I'm a Mac developer, so on and so forth. And the version of the Swift language I'm using. Same thing with Java. I could just associate a string with Java, for example, like what platform am I enterprise Java developer, right? So forth, so on and so forth. Same, I can associate a string with Objective-C. Cool. So those are called associated values. I could put an int here as well. I could put in a bool, so on and so forth, depending on what the use case is. In our case here, we're just using a simple illustration case. So we'll say, we'll create an instance called language. And language is going to be instantiated from our enum language. We'll use Swift. So here we see we could use Swift without any associated values, or we could use Swift with the 2 associated values here. So in that case, I will say Swift, and I will say I'm an iOS developer. And here I will give it a version. I'll say 5.3. So I'm currently on version 5.3. Okay. Next, here I will use a switch statement like we did earlier to switch on my language instance. And I will go ahead, I'll say case Swift. Okay, now the compiler already inferred that I have 2 associated values. It's a string and it's a double. Now I could use a constant to differentiate or to give my variable, to use my variable. I'll say let, in that case, it's platform. And second, I'll say let version. Okay, so basically I'm binding those 2 values, those 2 associated values to variables or to constants here, right? So the first one is a string, the second one is a double. Okay, this is pattern matching with what I have up here. So now in my print statement, I have the ability to now use those values. So in my print statement, I'll say something like looks like your, and I'll use platform here, string interpolated, developer running Swift. I'll use the version number that they passed in on Xcode 12.3. Okay. And since I'm only interested in just the Swift language for now, I'll put a default value. So anything that's not Swift, it will just default to some print statement here. I'll just say other language. Okay. And again, here we need to specify a default statement because we are not going through all the cases. The only case we used was Swift. If I use Swift, Java, Objective-C, then the default statement would not be required. Okay. As a matter of fact, the compiler would say would not be executed. So in our case here, we only use in one case, so we need a default to silence the error because this needs to be finite. Okay. Awesome. So now let's go ahead and run this code. And here we'll say, looks like you're an iOS, you're an iOS. Looks like you're an iOS developer, right? iOS from here, from the associated value, running Swift 5.3 version. We pass in 5.3 here on Xcode 12.3. Again, we have 2 associated values here. We're talking about associated values. We basically assign 2 associated values here, okay? So this is one way you could use associated values. Other ways you could use associated values in iOS development, which is very prevalent, is in error handling. More into that when we talk about iOS development. But for now, this is associated values. This is one way you could use it. Okay. Moving on to raw values. What are raw values? Well, again, we'll create a new enum here. We'll call this one user state. So user state has two cases. Either we have a new user or we have an existing user. Okay. Now we want to associate, or we want to have a raw value tied to that instance. So how can we do that? Well, we could use a colon here and specify the raw value or the raw type. The raw type will be a string. And what does that mean? Well, new user will also have this raw value of whatever message we want to pass in. In our case, we'll just pass in a message, say welcome, just like that. And here for existing user, if that person is an existing user, we'll say continue from where you left off. Good luck. Well, from where you left off. That's cool. Great. Okay, so we saw associated values. Let's see what the differences look like. Associated values, you specify the type, and when you create the instance, you pass in whatever whatever literal you want. In that case, I pass in iOS and I pass in 5.3. Well, when we talk about raw values here, the pack, it's already packaged with the raw type, the raw type. In our case, if it's a new user, it will always be welcome. Okay, it's not going to change. If the person is an existing user, the message will always be continue from where you left off, right? So let's see how that's used. Well, very simply, I'll create an instance of a user using user state here. And user state is going to be an existing user. And as I said, the raw value, how do we access the raw value on an enum instance? I'll print user, right? If I just print user, it's going to be new user. Let me just run that out. Actually, user is existing user here, sorry. So if I print user, it would be existing user, okay? That's what we created, an instance of an existing user. But if I want to get the raw value of that user, I put in dot raw value, right? And now if I run my code again, it won't say existing user. It will print the raw value of that user. In that case, it's continue from where you left off, okay? Again, those come in useful as you start building or continue building more iOS applications. You might come to a case where a user logs in, you want to probably put a message, you don't want to hard code a message. The message will always be somewhat tied to that new user, okay? Or it could be any, again, that raw value could be an int, it could be a bool, maybe you want to turn something off, maybe you want to turn something on based on the user state. So this could be very useful. Maybe it's an app theme, like if the person is a new user, you want to have a default color. Many ways to use enums. Enums are very, very powerful. Okay, so we spoke about raw values. Next, we'll go talk about implicitly assigned raw values. What does that mean? A lot of implicitness in the language, right? So here we'll create an enum. We'll call this one days of the week, okay? So that, and it's a raw value, so we'll make the raw value type an int. So earlier we saw a raw value of string, here we see a raw value of int, okay? And we'll create cases. Days of the week, we'll start off with Monday. Some people start with Sunday. I start off with Monday here. So Monday, we have Tuesday, we have Wednesday, we have Thursday, Friday, Saturday, Sunday. Okay. Before we do anything, let's see what the raw value of this Monday will be if we create an instance of Monday. So let's create an instance of Monday. We'll just say day. We'll use our enum days of the week. and we'll use one of our cases here. So we'll say Monday, and now I'll print day dot raw value. Let's see what the value is. Again, keep in mind it's an integer, so it has to be a whole number, whatever number it is, whatever the default value is. So here, if I run my code, I'll see 0, right? If I do not specify a default start value, the raw value of an integer will always be 0. So default start value of a raw of an int is 0. Okay, cool. So next question is, if I go ahead and I instantiate a day, say Tuesday, what day would that be? If Monday is 0, then what day is Tuesday? Well, let's just run it and find out. So Tuesday is 1, right? It increments. If you don't specify explicitly, it will increment whatever the start value is to that next value. So Monday will be 0, Tuesday 1, Wednesday 2, 3, 4, 5, 6. So Sunday will be 6. Let's verify this. So Sunday here, if we run it, in our case, Sunday will be 6. Okay, great. Now we could override that behavior by assigning it our own start value. I want to say Monday starts from day 1, just like that. Okay. Now, if I run my code again, this time Sunday won't be 6 anymore. It will be 7, which it is, because 1 is Monday, 2, 3, 4, 5, 6, 7. If I start off with 100, take a second and guess what Tuesday will be. Great, I think you guessed correctly. So Tuesday will be 101. Actually, where am I? Yeah, Tuesday. I did not assign Tuesday. Let's just do Tuesday here. So Tuesday will be 101, as you guessed correctly. All right, 101. Great. So those are implicitly assigned raw values. Cool, great. Lastly, let's take a look at initializing from a raw value. Okay, so we have our days. I want to create a new day. Let's say new day. I want to create a new day using my days of the week. And with this, I could use an initializer that takes in a raw value. The raw value needs to be an integer. It must be an integer because that's what we specified here. The compiler is inferring also that it's an integer. So whatever value you pass here has to be an integer. So I go ahead and I pass in 9. Okay. If I option click on new day, it's an optional. Why is it an optional? Because, well, the big reason it's an optional, maybe this is not a valid day of the week. If we see our days of the week here, we have 101. Well, we have 100. Let's go back to what we had. We have 1. So our valid days of the week, based on where we started with Monday, is 1 through 7. Anything before 1 or after 7 is not valid. So that's going to return nil, right? So if less than 1 or greater than 7 will return nil or is invalid. If less than 1 or greater than 7, day is invalid, right? Now, if the day is invalid, the best way to do this in Swift is have an optional. So that's why we have raw values returning an optional value, because maybe 9 doesn't exist. And one way we could find out if new day is existing is, you could go ahead and guess 1. Okay, yes, I think we could use optional binding. I think that's what you guessed correctly. So here I could say if let, I'll just use new day again here, or existing day, that's fine. And I will unwrap my new day, because remember, this is an optional. If it exists, it's going to put the value into existing day, and now I'll have access to existing day on line 94. So here I'll say existing day is whatever the existing day is here. Okay, cool. So let's go ahead and run this. And here I will see existing day is 2, right? Whatever 2 is here. So 2 in my case is 1, 2. It's Tuesday. 1 second. Let's see if this is nil here. No, this is not. This is not our answer here. This 2 is coming from up here. Sorry. So let's fix this because this does not exist. So here let's just put an exprint statement to catch this, because we were not catching it. That's why the 2 put us off. 2 is coming from here. So day does not exist will get printed. So if I run my code again, as expected, day does not exist because 9 is not a valid day. It needs to be between 1 and 7 for it to be valid. So now we could use any of those numbers between 1 and 7. Let's just go ahead and use 3. And now we'll have existing day existing. So existing day is Wednesday because it's 3. And if we look at our values here, our raw values, default value, Monday is 1. So if we assigned 3, 1, 2, 3 would be Wednesday. Okay. And again, if we want to get access to the raw value, existing day is, and we could say, and raw value is existing day dot raw value. It's going to be 3. So it's going to be Wednesday and it will be 3, just like that. Okay, great. So today we took a look at enums, how to use enums, what are enums, right? They're a finite group of related values, right? Here we have a finite group. We have 3 cases. We have the name of the enum, starts with a uppercase letter, conventional, right? We saw how to create instances of enums. Here we created an instance of Android from our cases here. We saw how to go ahead and figure out what the user selected, right? Using a switch statement. This is the most powerful way to figure out what the user selected. In our case, the user is an Android developer. So we just printed out, you're an Android developer. We saw how to iterate over enums using the case iterable protocol. Right, so this is the case iterable protocol. We saw how to inline cases if there's no difference between them, no associated values and so on and so forth. We saw how to iterate through it, providing that it is case iterable, because if we don't have conformance here, the compiler will have no idea what we're trying to do because it doesn't know that season is case iterable. We have to explicitly conform to case iterable here. If you could iterate through a collection, you could also find out what the count of a collection is. We spoke about associated values, how to have group values here, basically. So language, we have the platform you're on, we have the version number. Again, here we could have Java having a string. We could also have Java having a Boolean value. For example, is Java able to do Android development? Yes, that kind of thing. We also created an instance of language with our 2 associated values. Again, here you could easily put in like Mac OS, if you're a Mac OS developer, whatever it is, that kind of thing. And now you see you have, looks like you're an iOS developer if you were to run that code. Lastly, well, not lastly, we took a look at raw values as well. And raw values here, we could now have new user. So if my user logs in as a new user, I'll have welcome to our awesome app, something like that. If the person is a new user, if they're an existing user, we'll tell them continue from where you left off. Good luck. or whatever we want to print out, right? And again, we could have a string, we could have a bool, we could have an int, whatever we want here. Next, we spoke about implicitly assigned raw values. So you have an enum, you want to start at some point, and then from there on, you could have different numbers, well, incremented numbers. So from 1, 2, 3, 4. I could go ahead and override it if I want. I could say 2 now is 4, for example, right? So I could override it. In our case, we just want to keep it consistent, incremented. So 1, 2, 3, on to 7. We instantiated it and we printed out what the raw value was. The raw value was 2 in that case, right? Because of Tuesday. So Tuesday is 2. And lastly, we took a look at initializing from a raw value. So in our case here, we want to create a new instance of days of the week. We put in a raw value of 3. It has to be an integer because we specified an int here. And now it returns an optional because maybe the value we added is not valid, right? It's valid if it's 1, between 1 and 7, right? In that case, it's valid here. So we were able to create a new day. But if it wasn't valid, it will return nil and will get printed day does not exist. Okay? As always, thank you for watching. Happy New Year. Welcome to 2021. See you later. Bye-bye.